Okay, for time's sake, I'm going to skip ahead to number 4. On number 4, if you notice, the graph looks like this. We have the point A, and then B, C, D, and E. We're trying to figure out where is dy dx negative. This is saying where is the derivative negative, which is the same as the slope of the tangent line. So if I were to draw the slope here, or at B, at A and B both, I have negative tangent lines. So the answer is A. Or you can think about it, wherever f prime is negative, f is decreasing. So notice the function is decreasing here at A and B. Number 5 says, where does d squared y dx squared? This means the second derivative, double derivative, positive. That means the function is concave up. So concave up would be, here would be point of inflection where you change from concave down to concave up. So concave up is anywhere along this smiley face portion. So it's B, C, and D, which is D. Ticket number, oh, there's no 6. Number 7, I did the most in class. If you look here at A, the slope, which is the derivative, is 0. At B, the slope is also 0. And at C, we have a positive slope. So you're looking for the one that has A, 0, B, 0, C, some positive number. Since we're talking about the derivative, and so that is A. 4 does not exist. It would look like a sharp point. Okay, f of x equals negative x cubed minus 6x squared minus 9x minus 2. If I take the derivative, it's negative 3x squared minus 12x minus 9. Factor out a negative 3, 4x plus 3. So you're left with x plus 3 and x plus 1. Make sure you bring down this negative 3 though, because that will affect the sign. So negative 3, negative 1, negative 4 would be negative and negative, but this is also a negative. 3 negatives is a negative. Negative 2, positive, negative and negative, so positive. And then we have positive, positive, negative. So decreasing, increasing, decreasing. So if decreasing on negative 3 to negative 1, no. So A is wrong. Is B, F increasing on negative 3 to 1? Yes. So increasing on negative 3 to 1 is the answer. Number 9. X squared over x squared plus 4. Take the derivative using the chain rule, derivative of the top. The quotient rule times the bottom minus the derivative of the bottom times the top over the bottom squared. So we get 2x cubed plus 8x minus 2x cubed. So we have a fraction. These cancel out. And check top 0, bottom 0. The top equals 0 at 0. The bottom never equals 0 in this case. So you put 0 on the number line, f prime, plug in a negative number. Well, this is always positive. So if you plug in a negative number, you have negative and then positive. So decreasing, increasing. So the answer is increasing on A from 0 to infinity. Number 10. If I make a number line to illustrate this, we have 4 and 9. Positive, negative, positive. So increasing, decreasing, increasing. There's a minimum at x equals 9 and a max at x equals 4. F of x equals 1. Oh no, f of x minus 1 equals x cubed. We're on the interval from negative 2 to negative 4. I'm going to go ahead and add this one over. So f of x equals x cubed plus 1. Mean value theorem says the slope of the tangent line, which would be the derivative, 3x squared, equals the slope of the secant line, which is the change in y, f of 4 minus f of negative 2, over 4 minus negative 2. So plug in the 4 in here. So we'd have 4 cubed plus 1 minus a negative 2 cubed plus 1. Put that in parentheses. Over 4 minus 2 is 6. So we have 64 plus 1, which is 65, minus a negative 8 plus 1 gives us negative 7 over 6. So 65 plus 7 is 72 over 6, which gives us 12. So we set 3x squared equal to 12, divide by 3, get x squared equals 4. So x equals plus or minus 2, but we want to pick the one that's inside the interval, so we just pick 2, which is B. Number 12. Okay, absolute value of x minus 2 is shifted down 2. So on 1 to 5, it's just a line. So A is fine. B is x plus 2. The square root of x plus 2 would be shifted left 2. So on 1 to 5, we're fine because we're just this line. C, absolute value of x minus 2 would be shifted right 2. We're on 1 to 5. We have a problem. So it's this one because you have to be continuous and differentiable. Points of inflection, take the derivative twice. So we have 3x squared minus 12. Take it again and get 6x. Set equal to 0, you get x equals 0. So make sure it's indeed a point of inflection. And it is, the signs change. So you plug in 0 into the original function. So we get 0, 0, which is B. Number 14, x to the 4th plus 6x cubed minus 10, 4x cubed plus 18x squared. Take it again, 12x squared plus 36x. It's double prime, so s equal to 0. Common factor is 12x. You're left with x plus 6. X equals 0. X equals negative 6. So negative 7 would be negative, negative, so positive. Negative 5 would be negative, positive, negative. So indeed we do change at both these places. So negative 6 comma f of negative 6 and 0 comma f of 0. So, oh, this is supposed to be a 3. Excuse me. You factor out a 12, that's 3 there, so negative 3. The signs are the same. 3 comma f of 3. If I plug in a 3, 3 to the 4th plus 6 times 3 cubed minus 10, I get 3 to the 4th let's see, 27 times 18 minus 10, oh no, 27 times 9, minus 10, so that is 9 times 7, 63, 18, and 6, 243 minus 10. When you plug in 3 here, you're going to get 91, negative 3. That's what I was having a problem. You get negative 3 comma negative 91 and 0 comma negative 10. Go back to the original function and plug these both in. So that's choice A. Number 15. 8x cubed minus 2x to the 4th. Take the derivative once, we get 24x squared minus 8x cubed. Take the derivative twice, we get 48x minus 24x squared. Factor out 24x, so you're left with 2 minus x. So x equals 0, x equals 2, negative 1, negative, positive, negative. 1 would be positive, positive, positive. and then negative, so concave downward from negative infinity to 0 and 2 to infinity, so that is choice A. Number 16. This function here has a minimum at x equals 6. So if you have a minimum, you've gone down and then up. The function's gone down and up, which means the derivative has changed from positive to negative. So is f prime positive on the interval from 6 to infinity? No. B, f prime positive on all of them? No. C, f prime negative on the interval from 6 to infinity? Yes. Relative minimum of the equation 3x to the 5th minus 5x cubed plus 12. Anytime you hear min, you think first derivative. So, derivative gives us 15x to the 4th minus 15x squared. We need critical values to set equal to 0. Factor out the GCF, so you're left with x squared minus 1, which is a difference of squares. X minus 1 times x plus 1. So you get x equals 0, x equals 1, and negative 1. Negative 2 would be, this is always positive, so just figure out these two. Negative and negative, so positive, and negative 1/2. Negative, positive, so negative 1/2 would be negative. And positive, so also negative, and then after 2, I mean, it'd say 2 would be positive and positive. Increasing, decreasing, increasing. So relative min at 1 only. So 17 is choice A. Number 18. Anytime we have absolute, we need to do the closed interval test. So x, f of x, we're on the interval from 0 to 6. So plug in 0, you get 0. Plug in 6, and I do believe you get 54, and then you need critical numbers. So 3x squared minus 6x minus 9. Factor out of 3, you're left with x squared minus 2x minus 3. So x minus 3 times x plus 1. So you have 3 and negative 1. But this is the only one on your interval, so you plug in your 3 and evaluate it. And then you compare, we're looking for the maximum value. And we end up getting 54. So this ends up being your answer, but you need to check this one also. 19, same idea. You do f prime of x and you get 6x squared minus 6x. And you need to test the endpoints, negative 2 and 2. X squared minus 1. So plug both these in and compare the values, and your answer ends up being